here's the reality, guys. This practice midterm is almost identical to the midterm, right? As you can see, I duplicated the same type of question a couple of times, some 2, some 3. And if you do well on this practice midterm, you're going to do great on the actual midterm. So there's 2 of the same type of questions on number 1. I give you 2 functions, and it's all about function notation. And you got to know what r of q of x means, and you also have to know what q of r of x means. So I'm just going to explain one, and then you could try the other. So I'm going to begin with this first one, and you could try the second one. The first one says r of x is the function x squared plus 5, and q of x is the function x minus 3, and the notation is r of q of x. So you have the r on the outside and the q inside the r. Okay, so what this means is that you're going to plug in the q function into the r function. So how should we do this? You're going to start by rewriting the r function, but instead of x's, putting parentheses. Okay, so we're going to rewrite this as parenthesis squared plus 5. And we're going to plug in the q of x function in here. Okay, now here's the deal. Let's take a step back and go even more basic. If I asked you to find r of 5, what would you do? You'd plug in 5. 5 squared is 25 plus 5 is 30. So r of 5 is equal to 30, right? What if I said find r of 1? Well, you'd plug in a 1. 1 squared is 1. 1 plus 5 is 6. So r of 1 is 6. You guys understand that, right? But if I don't give you a number, if I tell you r of q of x, then you got to plug in q of x into the r of x. So here's q of x. It's the binomial x minus 3. You're going to plug in this binomial of x minus 3 right in there. And then you got to do the math, okay? So what is the math? You're going to do the binomial squared, and you are not going to distribute that power of 2 that's incorrect. Because it's a binomial to the second power, you have to write out that binomial 2 times. X minus 3 times x minus 3. Now don't forget about that plus 5, it's still there. Now let's actually distribute. What is x times x? That's x squared. What is x times negative 3? It's negative 3x. What is negative 3 times x? It's another negative 3x. And what's negative 3 times negative 3? That's a positive 9. What about that plus 5? Bring it down. After that, you simply combine like terms, the minus 3x and the minus 3x. That'll give you a minus 6x. And then the plus 9 and plus 5, that's a plus 14. And what about this x squared? Just bring it down because you can't really combine it with the other x. And ladies and gentlemen, that is your answer. Sound good? Now on the next one, you're going to do it on your own, but they're asking you to plug in the r of x function into the q of x. So the outside one's the q, the little inside one's the r. So you're going to take this guy and plug it into that one, and it's super easy. Make sure you plug it in with parentheses. Anyway, you could double check your answers on Google Classroom. Bless you. I have the answers shown right here and somewhat of a written explanation. So we just got this one, and that's the answer that we got. You could try this one and check your answer right here, but that's on your own time. Let's move on to the next question. There's 2 versions of question number 2. I'm just going to go for the first one, okay? Find the inverse. So we need to first know what the heck it means to find the inverse. How do we do that? We simply switch x and y and solve for y. That's what you do. You switch x and y, and then you solve for y. Now, if you're like, well, what the heck? Well, there is no y. Remember, this is just the name of the function, f of x. It could be f of x, q of x, r of x. It could even be y, right? F of x is really the same thing as y. So maybe you want to start out by just rewriting it. Y equals 3x squared plus 5 instead of the f of x. F of x is the same thing as y. And again, how do we solve this thing, or how do we find the inverse? You switch the x and the y. So you're going to take this x and switch it with the y, and you're going to put the y where the x is at. So here it is. You're going to have an x right here equals 3y squared plus 5. So now that we've switched x and y, you're going to have to solve for y. So here's y. It's on the right side of the equal sign. It's definitely not by itself. There's a 3, there's an exponent, there's a plus 5. What do you get rid of first? You should get rid of that plus 5 first by subtracting 5 and subtracting 5. X take away 5 you cannot do, so you're just going to rewrite it. That's going to be an x minus 5 equals 3y squared. Now you almost have y by itself. You just need to get rid of the power of 2 and also the 3. What do you get rid of first? You have to get rid of that multiplication of 3 by dividing by 3. That'll cancel it out. And what you do to one side, you do to the other side, divide by 3. Now, since I can't really divide x by 3 or even 5 by 3, I want to just put them both divided by 3. Okay, the whole side divided by 3. If this would have been a 6, then it'd be a good idea to put the divided by 3 on the x and the divided by 3 on the 6. That way you could actually divide 6 by 3. But right here, you can't really divide by 3. So I'm just going to rewrite x minus 5, the entire thing divided by 3. So what do I have now? I have the fraction x minus 5 over 3 equals y squared. And I like to rewrite this with the y on the left side and the fraction on the right side. So I really have y squared equals x minus 5 over 3. Now you almost have y by itself. What do? We need to get rid of that square. And how do you get rid of the square? Square root. That's exactly right. So we're going to take the square root of this and the square root of that. However, just remember that whenever you apply a square root when solving an equation, you're going to have to put a plus or minus in front of your answer, in front of your square root. So yes, it's true that the square root and the square eliminate themselves, they undo themselves, so you have a nice beautiful y, but you do have to put a plus or minus in front of the answer on this other side. And on this other side, you can't really do the square root of that or the square root of that. Like, let's pretend you'd have a 9 down here. Then it'd be a good idea to take this yellow square root and put it on the top, put it on the bottom, so you could actually do the square root of 9. But it's not a 9, it's a 3, and you can't really do the square root of 3, can't even simplify it. So right here, it's better to just leave it inside the square root, and that is your answer, the square root of x minus 5 over 3. So y equals plus or minus the square root of x minus 5 over 3. Does that make sense? Any questions on that? No? Okay, so once again, if you understood that you switch x and y and solve for y, then you should be able to do this next one. It's the same exact process. And on Google Classroom, you should be able to check your answer. And see if you get that answer right there. The one that we just did, we got that answer, and it has some explanations and stuff. So that's how you could verify your answers. That's on Google Classroom separately. Okay. Moving on to number 3 on the midterm. And by the way, the midterm questions are going to be mixed up. That doesn't mean that you're going to have number 3 on the midterm. It's going to be the same as this 3. But one of the questions on the midterm will be this question. And it's written 3 times, so you could practice a lot. Which one should we do? This one, the middle one, or the right one? It's all the same thing. I'm going to go with the right one. Why not? Okay. So I'll do this one. You guys could do the other 2. And again, you could check your answers on Google Classroom. So this is not a square root. This is a cube root. Cube root. So when you have square roots, you want perfect square numbers. Like you would like the square root of 9, the square root of 27, or 25. Right? A square root of 81 when it's a square root. But this is a cube root, so you want perfect cube numbers. So maybe it'd be a good idea to just make a list of perfect cube numbers, right? Like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. If you're like, man, I don't know how to multiply. Okay, use a calculator, right? 5 times 5 times 5 is 125. 6 times 6 times 6, 216. And yes, I used the calculator on that one. 7 times 7 times 7, that's 343. And this continues forever, right? Now, why do I make this list? Because when you have a cube root of anything that's being multiplied on the inside, you're going to be able to split that root, okay? So you're going to be able to split that third root and put it on the 625, and split that third root and put it on the x to the 11th. Okay. Now, with this number, you would like a perfect cube number. It'd be cool if we could rewrite this 625 as like 8 times something. That way we could split it and actually do the cube root of 8. But you don't want to go with the smallest one. You want to go with the biggest one, right? So looking at these, which number do you think would work to rewrite 625 as one of these numbers with multiplication? Anybody? Which one of these? Like, pick a number. 8, 27, 64, 125. 2, like, is 343 times 2 625? No, it's not. Okay, so which one of these would work? 125. 125 times 5, right? I think so. Okay, so we're going to rewrite this thing as 125 times 5. Double checking on the calculator. Yes, 125 times 5 is 625. So we're going to rewrite it with multiplication. That way we could split the third root. And now you could actually do the third root of 125. That's 5. And what about the third root of 5? That just comes down. You can't really do it. So far, this gave us this part of our final answer. Now let's do this guy over here. Now there's different ways of doing this. One way is to think, well, power over root. That means that we want this to be divisible by 3, okay? So 11 divided by 3, that doesn't work. I wish this were a 12, but it's not a 12. So could I rewrite this with multiplication to get a power that's divisible by 3? The answer is yes. I could rewrite this as x to the 9th, that's divisible by 3, times x to the 2nd, because 9 plus 2 is 11. So that'd be using rule 1 of exponents to rewrite x to the 11th as x to the 9th times x to the 2nd, okay? And I'll show you a different way in case you don't like this. But now you could split the third root and the third root. That way you could actually do the third root of x to the 9th. That is 9 divided by 3 is 3, so you really end up with the x cubed. And then over here, you cannot do it, so it simply comes down. So that is the third root of x squared. Now that you have your answer, what is our answer here? It's 5 times the third root of 5 times x to the third times the third root of x squared. Whenever you have an answer like this, put the nice terms that are outside the radical together in the front. So take that 5 and the x to the third, write it out, 5x to the third. And then you could take the square root, the cube root of 5, and the cube root of x squared, and put them together underneath one cube root, 5x squared. And ladies and gentlemen, this is your final answer to this question, right? Now, I did say I would explain a different way of simplifying this guy, okay? When we simplified, we ended up with x to the third times the cube root of x squared. I want to show you a different way of getting that. That's to actually change it to a rational exponent. So you could have said, I'm going to change this to a x to the power of 11 divided by 3. And then if you actually thought about what is 11 divided by 3, well, it'll go in 3 times. That'll be a 9, and you'll have a remainder of 2. So that improper fraction could be rewritten as 3 2/3. Now, that means that I could rewrite this as x to the 3 2/3, which means that I could rewrite this as an x here and an x there with the power of 3 there and the power of 2/3 there. And then that is the equivalent of x to the third cube root of x squared, changing it back to a radical power over root. There's a power, there's a root. So we end up with the same thing in yellow here as in blue there. It's just a different way. So it's totally up to you. I think thinking of changing this to something divisible by 3 is easier by splitting it right here and not even changing it to rational exponents. But then again, if you feel more comfortable with rational exponents, you could change that to an improper fraction, change it to a mixed number, split the base, and you have the same thing as before, right? But anyway, this is your final answer. That was just an alternative way of simplifying this. It's up to you. Whatever you feel more comfortable with. Let's move on. And of course, you have 2 more problems that are very similar to that one, similar to the one that you're going to see on the midterm. So we're on the back side. Right here, we want a graph, and there's 3 of them. I'll do 2 out of the 3, and you could do 1 on your own. Should I do the first one or the second one? Pick one.
Third one.
Okay. First or second? All right. Second. Nah, first. All right. So there's different ways of doing this. There's like so many different options here. Let's start with the most basic, the most straightforward that you could always do. You could identify h, which is positive 3, the opposite of what you see here. And you could identify k, which is 2. And then you could ignore h and k. So check this out. I want to just box that in and ignore h and k. That way you could get your inputs and outputs to this square root function, but ignoring h and k. So again, you want to plug in nice perfect square numbers in here. Like, what could you do the square root of? It's really easy to do the square root of 0. So if you do plug in 0, that'll give you 0. How about the square root of 1? Will that work? Yeah, the square root of 1 is 1. How about the square root of 2? Doesn't work. Square root of 3 doesn't work. I mean, it works, but it gives you nasty decimals. But the square root of 4, that's a beautiful answer. 2, square root of 5 doesn't, square root of 6 doesn't. But the square root of 9 is a beautiful answer. That's 3. Now, this is ignoring h and k, if it wasn't there, right? Now, this is the pattern that you could use whenever you have an a value of 1. So if h and k weren't there, you'd start out 0, 0, 1, 1, 4, 2, 4, 2, and then 9, 3, right? And it would shoot off in that direction from the beginning point 0, 0. But if you want your actual coordinates, once you ignore h and k, you get these coordinates, and now you could apply h and k to get your actual coordinates. Now, what do I mean by actual coordinates? We're going to take the x values, and we're going to add 3 to them, and we're going to take the y values, and we're going to add 2 to them. Because after all, the h value is the change on your x-axis. It's the left-right shift, and the k value is your change in your y-axis. It's the up or down shift. So we're going to shift these numerically 3 to the right on the x's. So you're going to take that 0, and you're going to add 3 to it, and that's going to be a 3 right there. You're going to take that 1 and add 3 to it. That's 4. You're going to take that 9 and add 3 to it. That's 12. Oh, wait, I messed up. I forgot the 4. Take the 4, add 3 to it. It'll be a 7. And take the 9 and add 3 to it. It'll be a 12. Now let's go to the y values, and we're going to add 2 to the y's. So 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. And 3 plus 2 is 5. So these blue coordinates, this blue xy table, is your actual final coordinates, including everything, right? Including everything. Those are your actual coordinates, including everything. So again, you could identify h and k, ignore h and k, and then modify by adding the h's to the x's and adding the k's to the y's. So let's get these coordinates. The coordinate is 3, 2. 1, 2, 3, 1, 2. Put a dot right there. And you have the coordinate 4, 3. 4, 1, 2, 3. And you have the coordinate 7, 4. So that's 1, 2, 3, 4, 5, 6, 7, and 4. And last but not least, 12, 5. But that's going to be way off the graph, so I'm not going to do that, right? Anyway, that's one option, and I hope everybody understands that. That's your graph. The other option is to go strictly with the pattern or the modified pattern from your beginning point. The most important point is 3, 2, your hk. Always think opposite on h, take k for what it is. So if you did start at 3, 2, and then from here you could think of the pattern, and you don't even have to memorize this pattern. You could think of it from here. You could say, like, what is the square root of 1 as you move to the right? The square root of 1 is 1, so you get that dot. Then you go back to the beginning point. What is the square root of 4? 1, 2, 3, 4. What's the square root of 4? 2. Boom, right? Go back to the beginning point. The next perfect square number would be a 9. What's the square root of 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the square root of 9? It's 3. 1, 2, 3. So it'd be up here. Make sense? So you could use the pattern if you want. I like to use the pattern. So I always find my beginning point, and then I use the pattern or the modified pattern to get my other coordinates. But you don't have to. You could do what we did right here. It's very straightforward. Identify h and k, ignore h and k, come up with your points, modify your points by adding h to your x's, adding k's to your y's, and those will be your final coordinates, all right? Now, yet another way of doing it. Another way is to, from the beginning, think of the entire thing and be like, okay, I would like a 0 in here so I could do the square root of 0. So what number could I plug in to get a 0 in here? What number could I put right here to get a 0?
3.
A 3, right? So you could think of the whole thing and be like, okay, I want to plug in a 3. That way, it'll give me a 0, and then the square root of 0 is 0, and 0 plus 2 is 2. You see how you get the same points anyway, right? And then you can think, oh, I want to get a 1 in here. What number could I plug in to get a 1 so I could actually do the square root of 1? What could I plug in here? A 4, because 4 take away 3, so I could plug in a 4. That way, when you plug in a 4, 4 take away 3 is 1, the square root of 1 is 1, and 1 plus 2 is 3. You see how we're getting the same points, right? Obviously, looking at the whole thing, thinking of what you could plug in that would be nice, that you could actually do the square root of, that takes a lot more time. So I guess the first option is best, where you ignore h and k, come up with your coordinates, modify your coordinates with your h and k. That way you can get your final coordinates. So you're going to be able to do this one, number 4. And again, you could check your answers on Google Classroom. It'll be right there. And let's go to this one. This one has an a value of -2, even more fun, right? So how do we do it? The first method, we identified h and k. My h is what? -3. My k is what? 4. Okay. So that means that my beginning point is -3, 4, which is fantastic. And you could use a modified pattern from there, but let's go with the first method that I showed you on the last one. We already identified it. Now let's ignore it. Okay. So we're going to come up with our coordinates ignoring h and k. So here we go. When I plug in a 0 in here, let me put a 0 right there. When I plug in a 0 in there, you get the square root of 0, which is 0, and 0 times -2 is still 0. Again, we are ignoring h and k. We're going to plug in a 1, because when you plug in a 1 right there, the square root of 1 is 1, and 1 times -2 is -2. Now let's plug in a 4. Why? Because the square root of 4 is 2, and 2 times -2 is -4. Let's plug in the next perfect score, number 9. The square root of 9 is 3, and 3 times -2 is -6. Are you with me? Okay, so these are not your final coordinates. These are the coordinates of this guy. Whoa. These are the coordinates of this guy, ignoring h and k. So we actually now need to modify these guys, including h and k. So how do we modify the x's? We subtract 3 from all of them. How do you modify the y's? You add 4 to all of them. Okay, so here are your final true xy coordinates. So instead of 0, 0, let's go with the left side, right? Instead of 0, what is 0 take away 3? 0 take away 3 is -3. Instead of 1, what's 1 take away 3? Oh, that's -2. Instead of 4, what's 4 take away 3? Oh, that's 1. Instead of 9, what's 9 take away 3? Oh, that's 6. Now let's do the y's. How are we going to modify the y's? By adding 4, because the k is +4. So you're going to go 0 plus 4, that's 4. You're going to go -2 plus 4, oh, that's 2. You're going to go -4 plus 4, oh, that's 0. And what's -6 plus 4? That's -2. So the blue xy table is the actual final modified coordinates of your final graph. Does that make sense? So where is -3, +4? It's right here. Where's -2, +2? It's right here. Where's +1, 0? It's right there. And where's +6, -2? 1, 2, 3, 4, 5, 6, -2 right there. So there's our graph. It starts right here at the beginning point, shoots off in this direction, going down and to the right forever. You know, one thing we haven't mentioned here are domain and range. Just for kicks here, we're going to find the domain. Those are your x values. And if you think about where the x values are at, this graph begins right here. It doesn't exist at -10. It doesn't even exist at -5. Where does it start existing on the x's? Right here. And what's that x value? -3, right? And it exists to the right of -3. So x is greater than or equal to -3. That's your domain. How about the range? Well, the range are your y values. And if it begins right here and goes down forever, well, obviously it doesn't exist at the y value of 10, nor at the y value of 5. It starts existing at 4. Did I say 5 up here? 5. Or it starts existing at 4 and below. So the range is y is less than or equal to +4. Guys get it? Fantastic. All right, so you guys could work on this guy. And now let's jump to number 5 on the midterm. They're both the same. Now, some of you are thinking, wait a minute, there's no variables in there. I could probably do this on a calculator, and yes, that is true. But the calculator only gives you an answer, and like I said before, this is an open response test. You need to show all the correct work to be able to get full credit, okay? So these are square roots, not cube roots. If there were cube roots, I would make a list of perfect cube numbers. But these are square roots, so you want perfect square numbers. What kind of numbers? 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on, right? But we want the square root of one of these numbers. And as a matter of fact, look, we do have the square root of one of those numbers. What is the square root of 25? The square root of 25 is 5, right? So this guy is actually the number 5. So what do we really have here? You have the -4 times 5. So this first part, -4 times 5, that's a -20. So far, so good. Now, this next one, 12's not up here. That's not a perfect square number. So I need to rewrite this with multiplication to get one of these numbers. So you're not going to do 2 times 6 because 2's not up there, 6 is not up there. You're going to do 4 times 3. So we're going to rewrite this guy as 4 times 3. That way you could split the root. Now, why would you split the root? Because the square root of 4 is a nice, beautiful answer too. And what about the square root of 3? That simply comes down. Also, let's not forget about this +4 that's being multiplied in front of the square root of 12. We need to bring that down. So we're going to put the +4 that's being multiplied in front of the 2 square root of 3. So we still need to multiply the 4 times 2, and we will get +8 square root of 3. Okay, so far we have -20 plus 8 square root of 3. Now let's move on to the last part of this expression. The square root of 27, it's not a perfect square number, but I could rewrite that as 9 times 3. That way I could split the root, and I could actually do the square root of 9, which is 3, and then the square root of 3 just comes down because you can't really do anything with it. However, don't forget about this -4 out in the front. So you're going to bring down that -4 right in front of that 3. Now, that's not a -43. That's a -4 times 3 times the square root of 3. So what you really have here is a -12 of those square roots of 3. So again, we had the -20, we had the 8, the +8 square root of 3, and you have the -12 square roots of 3. So those are 3 terms, and if you look at it carefully, these guys are the same type of terms. There's 3, the square root of 3 and square root of 3. Right here you have 8 of them, right here you owe 12 of them. So you could actually combine these guys. If you have 8 and you owe 12, how do you end up? You owe 4. That's right, you owe 4. So we're going to put a -4 of those square roots of 3's. What about the 20? Just simply bring it down, -20 in front. So there's your final answer, -20 minus 4 square root of 3. So if you understood that, you should be able to safely do this one and then check your work. Like, let's say I want to check this answer on Google Classroom. You'll be able to see that answer right there. 20 minus 4 square root of 3, okay? So try that one, check your answer on Google Classroom. And for the last one, on this first part of the midterm is 12 questions, and we've gone over 6 types of questions here. So let's do this last one, and then you could try the other one. We're solving, but it also says, and verify your solutions, right? So we're going to solve this guy. How do you solve an equation that has a square root in it? First, isolate the radical. So let's get rid of the +3 by subtracting 3. Subtracting 3. You're going to end up with the square root of 2x plus 6 equals 7 take away 3 is 4. Now that it's isolated, now you could get rid of the square root by doing the opposite of a square root. What is the opposite of a square root? It's the power of 2. So you're going to put the power of 2 here. And what you do to one side, you do to the other side. So the square root and the square, they undo themselves. And now you just have that radicand value that's now a regular value, 2x plus 6. And it is equal to 4 squared, which is 16. Now it becomes a simple algebra 1 problem where you subtract 6. You end up with 2x equaling 10. And then you divide by 2, you get x equals 5 as your answer. Maybe. Why do I say maybe? Because it says verify any solution. That means you got to double check it, okay? And if you don't double check it, you're not going to get full credit because that's what the instructions say, all right? And this is a 3-point question. So maybe 1 point for understanding that you have to isolate it and do the math. And maybe you only get 1 point because you made a mistake. But maybe you get 2 points. But then you got to double check your answer. That's where you get the 3rd point. So verify your answer. We're going to go back to the original. Here's the original. It's the square root of 2x plus 6 plus 3 on the outside equals 7. Now, notice that when I said x, I put parentheses. Why? Because I already know that x is 5. And I'm actually going to plug in that 5. And when you're doing this on the test, you might as well write up here double checking. Double checking, right? You're verifying your answer. You could write verifying your answer, checking my answer, whatever. That way I know that that's the work that you're doing. So when you do this work, when you go 2 times 5, that's 10. Bring down the plus 6. You still have the plus 3 on the outside, and it should all equal 7. So inside the square root, you have 10 plus 6, that's 16. You still have the plus 3, and it should equal 7. And we know that the square root of 16 is actually 4. And 4 plus 3, does that equal 7? Heck yes. That's what you call double checking. You're absolutely positive that this is the correct answer. 3 points. 2 for showing your work, getting that correct answer. And 1 more point for verifying your solution. Let's do this next one. I said I wouldn't do it, but you know what? Might as well. Check it out. When you subtract 7 and subtract 7, what do you end up with on the right side? A negative. So at this point, and I'm doing this so you guys don't waste time, because at this point, if you have the square root of something equaling a negative, you know that that's impossible, right? There's like the square root of 25 is positive 5. The square root of 36 is positive 6. There's no way that you could take the square root of something and get a negative 6 or a negative 5 or a negative anything. It just doesn't work. It just can't happen. So at this point, if you end up with the square root of something equaling a negative, or maybe the square root of something is less than or equal to a negative or less than a negative, you know that's impossible. So you could just stop right there and say no solution. Well, I guess there's not one for you to practice, but you know, hey, copy that one again in your notebook and try to do it separately, see if you can get the same answer. So that concludes our review of the first half of the midterm. We will have the second half the next time we meet, and I'll explain it, and you guys are going to study it, and then you're going to ace the midterm. Sound good? All right.